Retrieval using composite queries. The topics are the union operator, subqueries, outer references and correlated subqueries, quantifiers, subqueries versus joins, subqueries in the from clause. Let us start with the union operator. The union operator combines the results of separate compatible queries. Let us see one example. Provide a table which contains the staff number, name, and position of each doctor and each nurse. See, the query is used to retrieve the staff number, name, and positions of all doctors and nurses. So let us see the content of doctor table and the nurse table in ISQL. So make sure you have connected to the hospital database. Let me see what is in doctor table. Select star from doctor. So you are able to see the results. You can see here the first column is the staff number, doctor name, and position. So let us see what is in the nurse table. So you can see here the nurse table has staff number and the nurse name. There is no position here. So we need to solve this. The table should represent a nurse position as nurse. So we can just add a temporary column called position, and the position will be nurse. First query, select staff number, doctor name, position from doctor. The second query will be select staff number, nurse name, nurse from nurse. You can see the doctor table will give you these details. Let us run this query and see the result. So select staff number, nurse name, and we have added a temporary column called nurse. So the position of the nurses will be nurse. Now we can use the union operator to combine these two queries. So in order not to confuse, you can rename doctor name as staff name and position. And we can see the first query has staff number, and the second one we have the staff number. Then we have the staff name and the name of the nurse and position and nurse. Let us combine these two queries using union. Let us run this query and see the result. So it will take the titles of the columns what you have suggested or what you have placed in the first select. So it is giving you staff number, and here the doctor name we have renamed into staff name. So the second column title will be staff name, and the third column title will be position. So you can see wherever there is a doctor, you can see the positions as consultant, registrar, etc. And the nurse's positions will be nurse. Notes about the union operator. Union automatically removes all duplicates. Each query is processed independently. First, query defines the column names. The two queries must be union compatible. These are the conditions to be used in a union operator. So we have another exercise here. Why does the following query fail? Select patient name height from patient, union, select nurse name unknown, nurse. So we have seen the condition it should be, if you want to use the union operator with two queries to combine, So they should be what? Union compatible. Let us see these two queries are union compatible. So we have the first one, patient name, and you can see here nurse names. Of course, these are alphabets, but here you can see the second is height, and here you can see what? Unknown. Height and unknown are not of the same type. To correct the query, you can use what we have already seen, a function called cast. We can make use of the cast operator, the cast built-in function here. So the correct query is select patient name, cast, height as varchar 4 from patient, union, select nurse name, unknown from nurse. So now they are the height and the unknown are of the same type. You will be able to use the union to combine. So when you run the query, you can see the result. So the first query determines the column title, patient name, and what? It's written height. And here you can see patient from patient table and the nurse table. Here you can see this patient's heights are known and the nurse's heights are unknown. So if the data is not known, it is automatically displaying a message called unknown. So we can use the except operator here. Suppose you wanted to display all the students who did not submit an assignment. So except is like difference. It is subtracting. So this query result, it will perform the result of the first query and it will perform the result of the second query, and the second one will be subtracted from the result of first one. So except is subtraction operator or the difference. So in order to practice this one, we need to connect to hospital database. Sorry, we have to disconnect from the hospital database and we have to connect to the university database. First of all, let us see each one separate. Let me run them individually. So select student ID course code from enrollment. You can see here all the students enrolled in each course. Like C4 we have S01, C5 we have S02. So let me see the students who have submitted the assignment. Select student ID course code. We can see now the total number of students enrolled is 17. See the submitted students 22 rows. So we can see who did not. We wanted to know who did not submit the assignment. So for that we can use the except operator here. So you can see out of the registered or the enrolled students, there are 5 students who did not submit the assignment. Now let us use the intersect operator. We need to display the details of students who have submitted an assignment and also they have taken an examination. They have attended the examination. So both, we are going to display both the information. First one is who have submitted the assignment and the second one who sat for the examination. So we can make use of the operator called intersect. Intersect will combine the result of this two. So select student ID course code from assignment will give you the result of the students who have submitted the assignment, and select student ID course code from examination will give you the result of the students who attended the examination. So when you combine, so you can see both the students who attended the examination as well as they have submitted the assignment. So let me run the query who submitted the assignment. You can see 22 rows here, the students who submitted the assignment. And let me see the students who have attended the examination. So you can see here there are 6 students attended the examination here. Okay. So let me combine this two now. So to see all the students who have submitted the assignment as well as who have attended the examination. So these are the students who attended the examination as well as submitted the assignment. Are the following two queries are well-formed SQL? If not, why not? What request would the query be used to answer? Select staff number from nurse except select supervisor from supervisors. Yes, it is a well-formed query. It will list the nurses who are not supervisors, because here it will give you the list of all the nurses and here it will give you all the list of all supervisors. The difference will subtract the supervisors. So you are going to get the list. It will list the nurses who are not supervisors. Again, we have another query to make sure this is well formed. What requests would the query be used to answer? Select staff number, doctor name as staff name, position from doctor, union, staff number, nurse name, nurse from nurse. Yes, we have seen this query already. It's a well formed query which lists doctors and nurses with their positions. Are intersect and except commutative? Intersect is commutative while the except is not commutative. That means if you intersect, like for example, A intersection B is equal to B intersection A, but A minus B is not equal to B minus A. Union and sorting. Only one order by clause can be included. This clause is the last step in the logical processing of the query. The logical processing model is as shown in the diagram. Query 1. Process query specification according to the model in figure 2.15. So fine. Then we can see query 2. Process query specification according to the model. Then final table for query 1. Final table of query 2. Then we have the result from the first query and we have the result from the second query. So now we are going to use the union operator. Merge the final tables for each of the query specifications in the union clause, eliminating duplicate rows unless union all is specified. So we'll get the result of now the table, which is the union of tables, the result of both the queries total. And if we use the order the table according to the order by description, thus we have the final table for the whole query. So let us start with the subqueries now. Subqueries occurs when one of the clause in a query specification itself contains a query statement. It is used to formulate queries in which a particular row or group of rows of a table needs to be compared, either with values retrieved from related rows in one or more different tables or with values derived from other rows in the same table. The second of these comparisons is known as the correlated subquery. We have an exercise here. List the patient identifiers and names of the male patients whose weight is below the average for other male patients. So we need to display the patient identifiers, the names of the what is the condition? Only the male patients, and again whose weight is below the average of all the other male. So of course we know that we have to use the condition that gender is equal to male and we have to use the average aggregate function. So let us see. Select patient ID, patient name from patient where gender is equal to M and weight less than average weight. So we know that aggregate functions cannot be used along with the where clause. So this query will not work. This query will fail. So we have an alternate solution for this. So one option is we can determine the average weight from the first query. Select average weight as weight from patient where gender is equal to male. Will display the average weight of all the male patients. Once you receive the answer from this query, this answer can be used to compare the weight. So select patient ID, patient name from patient where gender is equal to M and weight less than the amount what you are getting from the previous query. So actually, this is done in two different steps. We have a better solution here. We can use a sub query to answer this question. So you can see the one the one we have written here. This can be written as a sub query in the condition after the equality operator. So you can see here, select patient ID, patient name, which is going to display the result from patient where gender is equal to M, and the second condition is weight less than, then the result of the query will give you the answer. So this is an example for a sub query. So let us run these queries one by one. Select patient ID, patient name from patient where gender is equal to M and weight less than. So let us run this query, and of course you will get a mistake, invalid use of aggregate function. So we know that we cannot use aggregate function along with the where clause. Second option is say the correct answer. So we will run the first query, will give you the average weight of male patients only. So once you receive, so you're getting 79.95. So let us substitute this value in the condition. So we have the answer. So let me remove this. So I have the value here. So I'm going to substitute 75.95. So I'm going to I'm able to receive the patient ID and patient names of all the patients who are male, as well as their weight is less than the average weight. So let us see the third one, which is use the